Hello everyone, this is Oshani from chinta.com. So today we will learn a lot. In this video, we will be using a problem from ISI BStat Entrance 2005. And if you have been watching me for some time, you already know this, that I love going from problem to concept. So we start with a problem as a motivation, and then we slowly learn all the concepts that are associated with it. I think personally, this is the best way to learn. So what is this problem about, and what are we going to learn using the problem in this video? The problem says that we have a triangle ABC. It's a right angle triangle with a right angle at B. AB is 7 and BC is 24. You drop a perpendicular from B to AC. They call it BD. The question is, what is the length of BD? Now, for some of you, this will be a very easy question. If you have been doing geometry for some time, then this is very simple. But we will learn certain things using this problem. So stay with me for that. So these are the things that we are going to talk about. The area technique. It's a very, very potent strategy to solve certain geometry problems. We'll talk about Pythagorean primitives, the geometric mean construction, and the quadratic solution strategy. So all of these things we will learn using this problem. Okay? So in between this video, I will just give you a couple of challenge problems. You already know this, that the best commenter is usually awarded by some book and some partial access to our outstanding mathematical courses. So if you want to participate in that, make sure to make a comment and respond to those challenge problems. This video is created at chinta.com. We offer outstanding programs in mathematical sciences. If you are interested, check the link in the description. My name is Oshani Dashgupta. I'm a faculty at chinta.com. I love doing mathematics. Let's get started with the notion of Pythagorean primitives. It's a very old story. Pythagoras, and in fact, before Pythagoras, the Indians, the Babylonians, and the Greeks realized one of the most important properties in elementary geometry. That is, if you have a right triangle like this, then the length, breadth, and the hypotenuse, they have a relation, and this relation is L square plus B square is equal to H square. Most of you will know this. What is a Pythagorean primitive? Well, it's three numbers which satisfy this particular relation. For example, 3, 4, 5. It's actually a Pythagorean triple, three numbers. So 3 square plus 4 square equal to 5 square. But it's a primitive because the HCF of 3, 4, and 5 is 1. The highest common factor is 1. In fact, you can multiply a Pythagorean primitive by any number and you will get another Pythagorean triple. So there are 2 times 3. Suppose you multiply all these numbers by 2 and you will get another Pythagorean triple. It will not be a primitive because its HCF is not 1. The three numbers HCF is not 1, but it will be a Pythagorean triple. It will satisfy this condition. So, for example, here we have 6, 8, and 10. And indeed, 6 squared is 36, 8 squared is 64, 10 squared is 100. 64 plus 36 is 100. So it works. In fact, this is one of the proofs that there are infinitely many Pythagorean triples. There are infinitely many triangles with integer side lengths. All three sides are integers. Which are right angle triangles. It's not always the case that there are infinitely many solutions, integer solutions to a certain equation. This particular equation has infinitely many solutions. In fact, I can write this as an equation, x squared plus y squared equal to z squared, and I can ask you how many solutions, integer solutions are there to this equation. And what we just said proves that there are infinitely many solutions to this equation. Human beings have studied these sort of equations for quite a long time. Farmer's last theorem is actually related to this, so I will encourage you to go online and check more about Farmer's last theorem. The question that we have here is also related to a Pythagorean triple. This number is 7, this number is 24. So 7 square plus 24 square, this is 49 and this is 576, right? 576. So if you add them up, you will get 625, which is the square of 25s, right? So 7, 24, 25 is a Pythagorean primitive. 7, 24, 25 is a Pythagorean primitive. And this side, AC, is 25. Now at this point, I'm going to give you the first challenge question. Here is a ladder diagram. A ladder of right triangles. So you start with 3, you have 4, and you have 5, right? Now what you can do is you can create another triangle like this, 5, 12, and 13. So you can check 5 square is 25, 12 square is 144, and they add up to give you 169, which is 13 square, right? So now you can keep on creating this sort of right triangles. So maybe you can do one more with 13 with another integer side and another hypotenuse. So I want you to create 7 of these triangles that sort of rotates like a ladder, like a spiral. Each piece is a right triangle which is sitting on the hypotenuse of the other. And I want you to create a general strategy of creating infinitely many triangles like this. So the question is, the challenge is this. Start with 3, 4, 5. Create 7 such triangles with integer side lengths such that each one can sit on the hypotenuse of the other, just like I have done. And give me a strategy that can produce infinitely many such triangles. Okay? So that's the question. Now, let's go to the area technique, because we want to solve this problem. And as I told you, it's a very simple problem. You just take the height BD as h, then the area of this triangle, you calculate it in 2 different ways. That is what the area technique is. This is obviously very easy in this particular problem, but in other problems it can be a little bit more twisted. But the general strategy is calculate area in 2 different ways. Calculate area in 2 different ways. So let's see how we do it here. So one way is that you have this right triangle. Maybe I can just copy this picture. Let's copy this. And let's paste it here. So one way is to calculate half times 7 times 24. Half height into base, right? Half height into base. And the other way is half h into 25, which gives you the same thing. Both of them will give you the area of the same triangle, so they are equal. This is a very standard strategy of doing this sort of problems, okay? So now let's cancel stuff out. So, oh, sorry, this is 12. So you have 7 times 12 times 2 by 25. That is equal to the height h. We have solved the problem that we wanted to solve, but we also learned a strategy that is useful in many other problems. Okay, remember this area strategy. 2 ways, count it in 2 ways and equate them. Okay, all right. So let's move on to the next topic, which is the geometric mean construction. The picture that we have is actually related to a very beautiful part of algebra, connects geometry and algebra. It's awesome. You have, let's say this AD is X, then CD is simply 25 minus X. Okay? What you can do, and this is, I'll show you why this is true. You can easily show that AD times CD, square root of that, is actually H. That is, the geometric mean of AD and CD is H. What is the geometric mean? So, the arithmetic mean, or the average is, let's say if I have 2 numbers, and the average of the 2 numbers, you just add them up and divide by 2. It gives you a sense of a central value of the 2 numbers, averaged out. But you know, there are more than one ways to find an average. There are different types of averages. This is just one of them. It's called the arithmetic mean. There are many, many types of averages. One more is the geometric average. The geometric average or geometric mean. In this particular case, instead of adding the 2 numbers, you multiply the 2 numbers. And instead of dividing by 2, you raise it to the power half. Of course, we have to work with non-negative numbers, otherwise we cannot extract the square root. But assuming that both of them are non-negative, you can calculate this geometric average. What this picture gives you is a geometric construction of this geometric average. And why that is true? Well, you can easily check this, that this triangle here is actually similar to this triangle. That is, triangle ADB is similar to triangle BDC. Why is that? Notice that if this is theta, if angle A is theta, then this is 90 minus theta. Because in the big triangle, this is 90. So if this is theta, then this is 90 minus theta. Now look at this small triangle. This one is 90 degree because it's a perpendicular. If this is 90 minus theta, then this is theta. Similarly, in this small triangle, if this is theta, then this is 90 minus theta. Okay? So, we have these 2 triangles as equiangular. Hence, they're similar, which means their ratios of corresponding sides are proportional. I've said this many times. What corresponding sides mean? Corresponding sides mean you look at the sides opposite to the equal angles. So let's do that. Let's look at the side opposite to 90 minus theta in both of these triangles. We have AD over BD. So AD over BD, that's the ratio of sides opposite to equal angles. In this case, 90 minus theta. That is equal to the sides opposite to theta, which is BD over CD. BD over CD. And that's it. You got it. Because if we cross multiply, AD times CD is equal to BD square, which means BD is equal to square root of AD times CD. That's it. So you found that BD is the geometric mean. BD is the geometric mean of AD and CD. This is a very powerful construction and it is useful in many problems. Okay? The final thing is that we want to use pure algebra to solve the previous problem, the one that was asked in ISI. So this is very simple. This is the quadratic solution strategy. So what you do, you notice that 7 square minus x square is BD square, right? So in this triangle, 7 is the hypotenuse, x is the base. So 7 square minus x square is equal to BD square. And in this triangle, the right-hand triangle, we have 24 square minus 25 minus x whole square is equal to BD square. That's it. So what you're going to do is you're going to equate these two things. So we have 7 square minus x square is equal to 576 minus 25 square minus x square plus 50x. So I just opened this up, this particular bracket up. Okay, I just expanded 25 minus x square. So now minus x square cancel off. And this is a standard thing that happens in quadratic solutions of geometric equations. The square terms get cancelled off, which is pretty cool because then you don't have to do the ugly quadratic formula thing. Okay. So now what you have is 7 square is equal to 576 minus 625 plus 50x. But we know already that this is 49 and this is also negative 49 and this is 50x. So you get 98 by 50 is x. 98 by 50 is x. So this x is 98 by 50. So now you can use the Pythagoras theorem again to find the value of BD from this particular triangle. Okay. So this is the general quadratic solution strategy. You just build equations using Pythagoras theorem, equate them, and then square terms cancel off, and then everything works out. You just find x and then you find the BD. Okay. It is useful in many problems. So I hope you learned something from this video. The second and the last challenge problem, the first challenge problem I already gave in between. The last challenge problem is this, that can you find a geometric construction of the harmonic mean? So I told you about arithmetic mean, the normal average. I told you about geometric mean, the geometric of average. The harmonic mean, it's another type of average actually. If you have two numbers a and b, the harmonic mean is 2 over 1 over a plus 1 over b. That's the harmonic mean. So can you try to find out the value of the geometric construction for the harmonic mean, just like we did for the geometric mean? If you can, tell me in the comment section. And I hope this video has been useful. Keep on watching Chinta's YouTube channel. Keep on doing great mathematics. You can stay subscribed to our channel and share it if you like it. I'll come back with more videos next time. Thank you and stay well. Bye.